So here's another example. This one is a sort of a continuation from an example in a previous video. The Laplace transform of cosine of 2t. So let's just write down what that is by the definition of the Laplace transform. It's an integral from 0 to infinity of e to the minus st cosine of 2t dt. Okay, so whenever you have integrals of this form, if you don't know where you're going with it, well, aside from being in trouble, it's always a safe bet to try integration by parts because we have a product of two functions here, and their integrals and derivatives are somewhat easy to calculate. So let's just do that. And maybe you have an intuition that one way is better than another, but I'm just going to say I'll define u to be e to the minus st, and dv is cosine 2t dt. Getting a little squish there. So now I can calculate the du by just taking a derivative with respect to t, and I get minus s e to the minus st dt. And coming around here, v is equal to, now when I take the antiderivative of cosine, I get sine of 2t, but then going backwards through the chain rule, I have to account for that 2 that will pop out, and so I have to divide by 2. So now the derivative of this guy with respect to t is cosine 2t, now multiplied by the 2, and they cancel, and I get cosine 2t dt. All right, so now I can rewrite this integral as 1/2 e to the minus st times sine of 2t evaluated from 0 to infinity minus the integral from 0 to infinity of, now we do v du, and let me just reorder that. Now this minus sign here is going to cancel with that minus sign to make a plus, and I'll have s e to the minus st from du, and then v, I'll have a half, which I'll put out in front, and a sine of 2t, and then I get a dt from the du. And so now I have one thing that I can simplify down. So you'll notice if I plug in 0 to here, I get 1, but if I plug it into the sine function, I get 0. So the lower limit's going to disappear. And what about the upper limit? Well, as long as s is positive, so I'm going to put that as a note on the side. I can only now talk about s positive because otherwise this integral doesn't converge. And so that means that I'm going to have a large value of t from this infinity multiplied by a negative in the exponent. That means it goes to 0. So this thing completely disappears, which is nice, plus 1/2 integral from 0 to infinity of s e to the minus st sine of 2t. Now this guy looks very similar to the one that we started with up here, except we've replaced cosine with sine. So some may get disillusioned at this point, but if you've taken an integral calculus, bells may be ringing. If not, I'm just going to tell you what you want to do. You want to keep going and use a similar substitution to the first one. U is equal to e to the minus st, and now dv, again, is going to be the trig function, and I'm going to put in the sine of 2t dt. Then du is minus s e to the minus st dt, and v is equal to, now remember with the cosine, the antiderivative with sine, it's got to have a minus sign in front, and I still have that half, and now this is cosine of 2t. So assembling this back using integration by parts formula, I get 1/2 multiplied by uv, so that's, well, there's a minus sign in v, so I'm going to put that up front here, and then another half multiplied by that guy. And let's remember that this half came along in front of the whole thing, so I have to multiply this half by both terms. but let's just write down the first one for now. So e to the minus st cosine 2t, and that's evaluated from 0 to infinity, and I subtract 1/2, which was this half over here that I had here and also have to have here, multiplied by the integral from 0 to infinity. And now, well, remember in our u and dv we did not include this s, but this s is constant with respect to t, so it can actually be moved out here. And so that means that I can remove, well, I can keep it out here in this expression. But now I get another s here. So there's a minus sign in front of that s, but there's also a minus sign in v. So when I calculate v du, those cancel, and I still have a minus left out front. But this s is going to be inside the integral, but it's not related to t. In other words, I can factor it out in front, and I'll get an s squared, where one of those s's came from this one, and the other comes from this one. Then the rest of the expression is e to the minus st. Oh, now I have an extra half, so I get another half coming out in front here. And the minus sign cancels with this one, so now I just have cosine of 2t dt. And you'll notice this thing here is exactly this thing here, except now I'm multiplying it by an s squared over 4. And so I'm going to rewrite this as Laplace transform of cosine 2t. So that is where the magic trick happens. What we have here is, well, let's first simplify that first term. When I plug in 0, this time it doesn't all disappear. What do I get? I get 1 here, and I get 1 here. So this whole term ends up being, well, it'll have a minus in front of it because it's the lower limit. So this will be minus 1 over, sorry, that'll be minus 1 over 4. This minus comes from the fact that it's the lower limit, and this minus comes from the expression that we had. Now the infinity part, again, as long as s is still positive, this exponential, when t gets very large, to going to infinity, will go to 0. So no matter what happens here, this all ends up going down to 0. And so I get 1/4 here minus s squared over 4 times the Laplace transform of cosine 2t. So how do we figure out what the Laplace transform is? We have the expression on both sides. Well, if we just solve this for this expression, in other words, bring this over to this side, the other side, and divide through by the coefficient in front of it. So what we get is the original Laplace transform expression from here, and then plus, now when we move this guy over, you get that, and that is equal to 1/4. So now we can factor out Laplace transform, and this will be 1 plus s squared over 4 equal 1/4. And so our Laplace transform then is just going to be 1 over 4 all divided by 1 plus s squared over 4. But I can multiply top and bottom by 4. And this will simplify to 1 over 4 plus s squared. And you'll notice in general, this 4 in both numerator and denominator came from a 2 squared, and that 2 was this coefficient here. So in general, if you have other numbers other than 2 here, you end up with that number squared over here.